There's one last set of concepts I'd like to cover before we move into some actual programming, and this is ACID. Now, again, like many of the concepts in this lecture, this is a very, very broad topic, and we're just barely going to scratch the surface, but I want you to be familiar with these concepts because this is the type of language we'll be using when we're building our system. So, ACID. This stands for A for atomicity, C for consistency, I for isolation, and D for durability. Atomicity refers to the notion that all parts of a transaction succeed or fail together. Now, we haven't talked about transactions, but these are basically just a group of statements. So if we were updating our database, which is actually not something we spent much time on, there may be the case where we're updating two tables at once, or updating multiple rows in our database together, in one cohesive unit. For example, if we're working from the Reddit example, if we had a link table and a users table, and somebody upvoted on a link, and that increases the user's reputation, we might increase the score of the link and also increase the reputation of the user. And those would happen in something that's called a transaction, which groups together multiple commands. Atomicity refers to the notion that either all of those commands are going to succeed or they're all going to fail, but we don't do part of it. We don't have just updating the link and not updating the user. Everything happens together. So this is a nice property for a database to have. Consistency refers to the notion that the database will always be consistent. And to work from our Reddit example, let's talk about this idea where we have a link and a user who have properties. If we have this notion that a link has a score that gets updated periodically, and the author or the submitter of that link also has a karma score that also gets updated at the same time, consistency refers to the notion that both the score and the karma will be consistent with one another, so that we don't update the score without also updating the karma. Basically means the database will move from one valid transaction to the next. So we'll never run a query that gets a link's updated score but can't also get the user's updated karma. So isolation refers to the notion that no transaction can interfere with another's. So let's say we have a link that is both getting two votes come in at the same time to increase the score of this link. That means we're going to be updating the link's score up and down and the user's karma up and down. And isolation refers to the notion that this upvote won't affect the computation of this downvote. If we were overwriting this link in our database, it would be a shame if the downvote was applied to the original link score before the upvote was applied, because the net score change in here should be 0, but it could be -1 if these aren't handled properly. And so isolation refers to the notion that each transaction cannot affect other transactions. Sometimes this is accomplished through locking. If two transactions affect the same row, only one can go at a time. And there are other ways of resolving transaction conflicts like that. Isolation refers to a database's ability to do that. Finally, we have durability. Durability refers to the notion that once a transaction is committed, it won't be lost. This means that, for example, if we send an update to our database and we update some rows, and the database says, okay, successful, that even if the database is turned off or crashes or is unplugged, we won't lose that data. That is durability. One thing I'd like you to know, I know we introduced a lot of new concepts in this portion here, but the important takeaway from this is that when you're talking about different database systems, they have different trade-offs. It's hard to have a database that's completely atomic, it's completely consistent, all transactions are isolated, and is completely durable. There's always some trade-offs.